Right, this is practice test number 1. We're practicing for the FSA. Do not write on the test booklet. Please copy down the information on a separate sheet of paper. Also, make sure you're listening. Watching the captions, like I see a lot of you do, that does not count as listening. Number 1, we have an expression here and we want to kind of evaluate it. All right. In the numerator, we have some addition. We're going to add these things together. In order to add scientific notation, they have to have the same power of 10. As you can see, they do not have the same power of 10, so I need to change one. It really doesn't matter which one we change. I'm going to change the second one right now into a power of -5. So I'm going to write this over on the side of my paper. You're going to write this on your paper. 2 times 10 to the -4th is the same as, well, if I change it, let me write it over here, times 10 to the -5th, I made that smaller, and that's why this number lines up here, right? If I'm going from here to here, I made it smaller. So if I make that smaller, I need to make this 2 bigger, which means I need to technically move the decimal point over 1 this way, making it a 20. Okay, so that is the same as 2 times 10 to the -4th. So now, what do I have? Let's write this down. We have 4 times 10 to the -5th power plus 20 times 10 to the -5th power in my numerator, and then we're going to divide it by 3 times 10 to the 7th power. Let's do that numerator first. Let's do our addition here. Once we have the same power, they're both of 5, now I can just add the numbers out front because the operation here is addition. So 4 plus 20 makes 24. Okay, and then I still have times 10 to the -5th power. So this is the same as above. And then our denominator is, of course, 3 times 10 to the 7th power. So all I did is I added my 2 numerators. Now I'm going to do my division, all right, where I divide my numbers out front. That gives me an 8. And then I do my power of 10. So it's keep your base and subtract those exponents. So this is 8 times 10 to the -12th power, which is answer B. Okay, number 2. An equation is shown. What are the possible values for m and n? There are so many different possibilities for answers here. I'm just going to give you a few. All you want to do is make sure that these 2 together are going to add to 7 because this is multiplication. And when we multiply, we keep the base and add those exponents. So I want m plus n to equal 7. Okay, so really there are a lot of numbers that add to 7. Pick any 2 numbers that will add to 7. Like 3 and 4 add to 7. What else adds to 7? You could have picked 2 and 5. There are many different possibilities. That's it. Number 3. We have a scatter plot. All right. Let's see, what does it say? Which statement is true for this scatter plot? Does it show no association? Does it show nothing? It shows me some kind of association. It looks to me like it's going downhill. Do you see that downhill motion? Well, that means it is a negative correlation. Make sure you take a moment and write that down. You can sketch the graph if you'd like. Just understand that is a negative correlation. Number 4, which number is irrational? Well, you better make sure you know the definition of rational and irrational. First, I wrote down irrational numbers cannot be made into fractions. You guys know that irrational numbers can't be made into fractions, whereas rational numbers can. Take a moment and write those down. And then we need to see which one is irrational. I want the ones that can't be made into fractions. Well, a repeating decimal definitely can be made into a fraction. I put the 3 over a 9. Okay, reduce if you want to. Let's look at B. Hopefully you already know B is the answer, but let me just go over why the other ones are not irrational. Well, C is already a fraction, but let's just double check because we can't have a square root in our fraction. The square root of 9, we do know that. That's 3, and 3 over 2 is a perfectly fine fraction. And then, of course, D, the square root of 16, is 4, and you can make that into 4 over 1. So everything else can be made into a fraction except pi. Number 5. The graph of a proportional relationship and an equation are shown. So take a minute, jot those down. We want to know the value of the greater unit rate. You should know this word right here. Another word for rate is slope. We want to find the one that has the greater slope. In your equation that you wrote down, please circle your slope. You should have circled 62. So that one is 62. Let's find the slope of this graph. Well, it's a proportional relationship. It did say it right here. So that's easy. I just take 1y over 1x. So really I could just take a point. I'd find a point that just lands somewhere nice, like maybe this one right here. It lands right nice on the crosshairs. So we're just taking that y over that x. So this is 300 over 5. And I can do that because it's proportional, because it goes through the origin. And 300 divided by 5 is 60. You can use calculators here. So which one has the greater unit rate? The equation does, and they want the value of it, so they're asking for the number, which is 62. Final answer. All right, let's do number 6. What is the measure of angle x in degrees in the figure shown? Make sure you take a second and draw that. All right, there are 2 ways to find this. You could do something where you find this angle. You know that all 3 angles in a triangle add to 180, right? So you take your 2 and you subtract it from 180, find this interior angle. And you also know that this angle here, I'll call it y, and angle x together add to 180, so I would subtract whatever y is from 180. But hopefully most of you at this point know the shortcut, which is that an exterior angle, let's write that down, exterior angle equals the sum of the 2 remote interior angles. So if I just take the 2 far away, that's what remote means, far away. If I just take these 2 far away angles and add them up, I'm going to get this exterior angle. So in this case, we have x, the exterior angle, equals the sum of 72 and 37. And you guys know sum means to add. So what's 72 plus 37? That looks like 109. All right, number 7, we have a graph. It's talking about some dealership sales. We have, I can't even read, vehicles sold on the y-axis and advertising on the x-axis. Okay, so what's going on? We want to create a table to show the relationships of x to y. All you're doing is making a table. You're going to pick any 3 points you can read because there's 3 columns, 1, 2, 3 columns here, and you're just going to put them in the table from the graph. So let's start with this point. I can read that point. That's the point what? 0, 0. I can also read, let's see, I've got, I think this one I can read. That would be 540. Reading the x, which is 5 here, and the y, which is 40. The last one that I see one way up at 1080. You see that point way over there? 1080. And honestly, I don't care as long as you picked a point and it made sense to me, that would be fine. There are many options for that problem. Okay, number 8. What is the difference of 4 times 10 to the negative third and 3 times 10 to the negative fourth written in standard form? So the difference means to subtract. I'm going to actually do this one 2 ways. I'm going to do it the way we did number 1, which would mean, all right, I have 4 times 10 to the negative third minus, because the difference means minus, and 3 times 10 to the negative fourth. All right, just like the first one, I need to make them both have the same exponent. So I am going to go ahead and change the second one. So I keep this one the same. Minus. All right, I'm going to change this to be a negative third power. So if this is going to be something times 10 to the negative third power, well, it looks like I made it bigger. I made the exponent, as you can see from here to here, I made it bigger. So I need to make the number smaller by 1. So I'm just moving the decimal over once, which would be 0.3. And you can put a 0 out front if you want. All right, so I'm just subtracting now these numbers. 4, you can put a 0.0 if you want, minus 0.3, which is, let's see, this is going to be a 3, this is going to be a 10, this is a 7, this is 3.7. And you keep that power of 10 when you add and subtract. So it's 3.7 times 10 to that same power, negative 3. But of course, they want it in standard form, which means I have to change this to standard form. So I have my 3.7 here. I'm moving the decimal 3 times, making it a smaller than 1 number because it's a negative exponent. So I have to move it to the left to make it a smaller than 1 number. So 1, 2, 3. So this is 0.0037. Okay. If you like that way, you're comfortable with that, you can move on, you can fast forward, but I'm going to show you the other way to do this. If I actually change it to standard form in the beginning, 4 times 10 to the third power, negative third would mean to move the decimal 3 times this way. 1, 2, 3. So I have 2 decimals there. And 3 times 10 to the negative fourth power would mean to move it 4 times. 1, 2, 3, 4. Okay, so I'm subtracting 0.004 minus 0.0003. There's a 0 here. Okay, and this is where you're going to get the same number because we subtract, we go like this. 10 minus 3 is 7. 3 minus 0 is 0. And that's the same answer. Either way works. No calculators for this. Make sure you're not using a calculator. Make sure you can do it on your own. All right, number 9. Which of the following is the best estimate for the average change in temperature associated with a 1 degree increase in latitude? In essence, they're asking us for the slope of a, we'll call it like a line of best fit, right? A line that kind of goes through the middle. What's the approximate slope of that? Okay, you're not going to get anything perfect. First of all, just look at the slope. Is it positive or negative? You guys know when it goes downhill, it's negative. So what answers can't it be? Can't be C, can't be D. So then, is it going down by 15 degrees for every degree latitude, or is it going down about 2.5? Again, nothing's going to be perfect. We're just going to have to estimate. So if I just take maybe a point here, which looks like, what is that, 25, comma, 65? And another point somewhere, again, it's not going to be perfect, maybe like this point-ish, which is 35 on the x. And is that also 35 on the y? Yep, 35 on the y. So we're just going to find the slope and see what happens. y2 minus y1 over x2 minus x1. So we have 35 minus 65 over 35 minus 25. This time we can use a calculator. All right, 35 minus 65 is a negative 30. 35 minus 25 is just 10. And if I divide this, this is negative 3. Again, that's not exact, but which one is that closer to, A or B? That's closer to B. It's closer to 2.5 than it is to 15. Okay, so you're not gonna, it's hard to get exact numbers here because it's just an estimate. But you're trying to find, there will be one obvious answer. So you'll be fine on these, okay? That is the answer for that one. All right, several functions represent different savings account plans. Which functions are non-linear, not straight? Okay, a linear function, you guys know what it looks like on a graph. It has to be some kind of straight line. Okay, in order to be a straight line, it has to have a constant rate of change. You have to have a y to the first power and an x to the first power. Okay, they can't be multiplied together. Can't do that. Can't multiply them together. But you can see A has a squared and D has a squared. The other ones, B and C, are considered linear because the y is to the first power, x is to the first power. C is the same way, right? We have first power, it's all good. Those are good, B and C for linear, but I'm asking for which ones are not linear, so I want A and D are non-linear. Make sure you write down whatever you need to understand that because you're going to be able to use these on your test. All right, select 3 side lengths in centimeters that can form a right triangle. Well, this is like a multiple select, right? You have to select 3 of them that will create a right triangle. So a right triangle, we know the sides in a right triangle. This is something you should be writing. The sides in a right triangle are as such. A squared, whatever that is, when you square it, plus B squared will always equal C squared. So to figure out which 2 numbers I can square and add up and make that equal another squared, I'm going to actually figure out what each of these numbers are squared. It'll make it a little easier. So what's 6 squared? 6 squared is 36, right? 7 squared is 49. 8 squared is 64. All right, 15 squared is 225. 24 squared, again, you can use a calculator for these ones, is 576. And 25 squared is 625. So what 2 smaller numbers will add up to one of these bigger numbers? Just kind of figure it out. Guess and check. Find 2 smaller numbers. You can pause the video and try it on your own. I found that if I take 49 and add it to 576, it will equal 625. So these three sides form a right triangle. We can do a 49, well, actually it'd be a 7, I'm sorry. It would be a 7. When we square it, we get 49. So a 7, a 24, and a 25 makes a right triangle. All right, select all the statements that are true based on this curve here, this graph of a curve. All right, as x increases, y increases. So as x increases, look at the number line for the x-axis here, which is your horizontal axis. Find out which direction it increases. That would be when we go to the right. So as we go from left to right here, is this graph increasing? No, it is not. It is decreasing, right? It's going downwards to the right. So nope, that's not true. All right, the rate of change for y as a function of x is not constant. Well, let's just stop there for a second. We'll finish that sentence. Is it constant? A constant rate of change is a straight line. So we already know that part of the sentence is true. The rate of change for y is not constant. That's true, yes. Therefore, the function is linear. Well, you know it's not linear, it's a curve. So that's no, so that's nope. C starts off the same way. The rate of change for y is as a function of x is not constant. That's true. Therefore, the function is nonlinear. Yes, that's true. All right. And this is multiple select, so let's check the last one. When x is 1, the function value of y is 5. So let's see. When x is 1, here's x is 1. We're going to follow it up to the line. Here it is, and read that y value. The y is 5. That is also true. All right. Number 13. We have 260 students. That is important information. Make sure you have that written down somewhere. 260 students were surveyed on whether they prefer apple juice or orange juice. It's supposed to say or here. A table of relative frequencies by rows is shown. They want to know how many more boys than girls prefer apple juice. Take a moment and make sure you copy down this table. Okay, how many more boys than girls prefer apple juice? Well, here's the percent of girls who prefer apple juice. It's not a number because you can see it's a decimal. Decimal means it's going to be a percent. And of course, because it says relative frequencies, I know we didn't really talk about it much, but relative frequencies mean a percent. So 59% of the girls like apple juice. And we got to figure out what percent of boys like apple juice. Well, we know if there's a total of 100% and 27% prefer orange juice, well, 1 minus 0.27, you can use a calculator if you want, is 0.73. So this is 0.73. In other words, 73% of the boys like apple juice. But it asked how many more boys. It's not asking how many more percent of the boys. We want to actually find out how many more boys. Well, we have, so we can figure out, first of all, let's do the percentages for a second. 73% minus 59% gives us 14% more. And if we multiply that percent times the number of students, we have 260 students. That will give us our answer, 36.4, or we'll round it to 36 students. 36 more. All right, number 14. We are going to solve this equation. We need to solve for x. There are multiple ways to do this. You can clear the fraction, but you know what? I'm just going to leave the fractions there. We're going to deal with the fractions. But I am going to change them all to the same denominator so that when I go to add and subtract, I can do that. Remember, when you add and subtract fractions, you need to have the same denominator. So let's just change 2/3 for a second into sixths. How many sixths is 2/3? Well, I multiplied here by 2, so I got to multiply the top by 2, so this is a 4. So I'm going to change the 2/3 to 4, 6x minus 1 equals 9 minus 1/6 x. Okay, we're solving. We want to get all the x's to one side first. I'm going to go ahead and undo the negative 1/6 x by adding 1/6 x to both sides. What's 4/6 plus 1/6? That's 5/6. X minus 1 equals 9. Okay. Then we're going to move all the constants to the right, so we're going to add 1. All right, we're going to be left with 5/6 x equals 10. And how do I get rid of that fraction? You want to multiply by the reciprocal. We're multiplying both sides by 6/5. You can put a 1 here if you need to. That will cancel off your whole fraction there, leaving me with just x equals, multiply that top. 10 times 6, 60. 1 times 5 is 5. And 60 divided by 5 is 12. Okay, 15. Analyze the system of two equations. How many solutions does the system of equations have? How many solutions? Well, we can go ahead and plug that in for y down here since it's a system. So instead of the bottom one being y equals 2x minus 3, it's now 2x plus 1 equals 2x minus 3. I just plugged that in for y right here. Just changed y to the 2x plus 1. All right, when I go to solve this, if I go to subtract 2x here to move it, well, it's not only going to cancel it on one side, it's going to also cancel it on the other side. What happens when the x's are gone? Well, you have to look and see what's left. What's left here? I have 1 over here and a negative 3 on this side. And does 1 ever equal negative 3? Nope. There's no number I could plug in there to make 1 equal negative 3. So there is no solution in this case. Number 16, televisions. The diagonal of a television measures 27 inches. Draw this for me. The diagonal of a television is 27 inches. If the width of a 27-inch is 22, we'll call this the width, that's fine, whatever. Calculate its height. I guess maybe we should pick the other one as 22 because that looks more like the height to me. What is the height? We can call that x. Hopefully you know that this is a right triangle. And you know, if you know two sides, you can find the third side because a squared plus b squared equals c squared. Which one's c? The one across from the right angle. So we could call x the a squared if we want. We could call x this one. So x squared plus 22 squared will equal 27 squared. Well, let's see. 22 squared is going to be 484. And 27 squared is 729. To solve for x, I need to get everything away from x, so I have to subtract this. And 729 minus 484 on my calculator comes to 245. And that's what x squared is. To find x, you know to take the square root of both sides. Because the square root of x squared is just x. So the square root of 245, first of all, let's write this down. This is, and do they want it? They say to round to the nearest inch means the nearest whole number. Let me write it down like this. This is 15 point, I'm going to stop here for a minute. 15.6, don't forget, x also equals negative 15.6. But can we have a negative length? No, you can't have a negative length, so we don't need that one. But we do need the top one. And if we round to the nearest inch, which is what it said to do, that means to this number right here. So if I round, it's going to be 16 inches. All right, a square is cut in half on the diagonal. You're going to think this is the same problem, but it really isn't. Square, try to make a square. Cut in half on the diagonal again. Each area is 0.245. Each of these triangles has an area of 0.245. So now we're not talking about the side lengths of triangles, are we? We're talking about the area of the inside. Well, kind of, actually. We need to know the side length of the square. Well, since it's a square, I'm only going to look at one of these for a second. So look at this here, okay? But since it's a square, all sides are what? All sides are the same. If I don't know it, I could call it x, right? Well, if that one's x, and they're all the same, then this one's also x, and this one's also x, and this one's also x. So I have the area would be length times width. I guess I don't need to just put one of them, I apologize. Length times width is x squared, right? And what is the area of everything inside? It's the two triangles added together is going to be equal to 2 of these things, 2 of the 0.245s. It's everything in here added together. So 2 times 0.245 gives me 0.49. Ooh, that looks interesting. How do I solve for one side? I need to take the square root. Yes, when I take the square root, I will get a negative number. Do I need the negative in this case? No, I do not. So the square root of 0.49 is 0.7. And this one doesn't give us any units. It just says square units. So there you go. That is the side of one of the side lengths. The diameter of a sphere is 6 inches. So we have I can never draw a three-dimensional sphere. That's good. Okay, diameter is the whole side across, right? Diameter is 6. Well, I want to know the radius. You guys know the radius is half of that, so the radius is 3. What is the volume of the sphere? Well, you guys gotta practice this, memorize this. 4/3 pi r cubed. There's no height in this one, so we need a third dimension. We need a third r. So we have 4/3 times 3.14 times 3 to the third power. All right, so I'm going to write this one more time. 3 to the third power is 27, and the rest goes in my calculator. 4 divided by 3, keep going, times 3.14, don't round, times 27 equals. I did not round at all in the intermediary, we call it. And I got 113.04. I'm going to double check my work. 4 divided by 3 times 3.14 times 27. Yep. Do I need to round? It does not say to round. So there we go. And we have inches. So cubic inches. 19. What is the sequence of transformations? Which sequence of transformations results in figures that are congruent? All right, this we need to have a lot of information, so get ready to write. You can pause the video when you need to. First of all, we need to know that congruent just means the same size and the same shape. Congruent means same size, same shape, same size, whatever, same thing. So let's talk about first all the different types of transformations that we have. Transformations, we've got a translation. That's a slide. Write that down. And then look up here, a slide. Right, I'm sliding it down, up, right, left. That's a translation. Remember that one? And a reflection is a mirror or a flip. You should be writing all of these down. I couldn't do it on my smartboard, so I just grabbed a picture here. That is a picture of a mirror image. Okay, this one got flipped across this line. I picked it up and flipped it over, and it landed over here. That's a reflection. We also have a rotation, which is a turn or a spin, and I can turn or spin this guy. Turn or spin it. That's a rotation. And then the last one is a dilation, means to make it bigger or smaller. And I can do that on here. I can make this guy bigger and make this guy smaller. Dilation. All right. And then let's go back up here and read. So which of these transformations results in figures that are congruent, meaning it will still be the same shape and the same size? Well, when I went and did this, did it change the shape? Did it change the size? Nope. When I flipped it in this picture right here, did it change shape or change size? Nope. How about when I turned it? Did it change shape or size? Nope. The only one that changes the size is dilation. Write that down. Dilation is the only transformation that does not remain congruent because it will change the size. Okay, when you're done, let's go back up here and find ones we want, ones that will be congruent. So if it says dilation, we know it's not an answer. So A, clockwise rotation, translation, there's no dilation, it'll still be congruent. Reflection, dilation, dilations will not be congruent, so that's not an answer. Translation's okay, reflection's okay, we're good. That one's good. Reflection's okay, translation's okay, dilation, nope. The answers are A and C. And the last one, number 20. The cost C to rent a car for D days is shown in the table. What is the cost of the rental deposit to rent the car? So is that a slope rental deposit, or is that a beginning value, a y-intercept, an initial value? A rental deposit, a deposit is always something you put down in the beginning. In the beginning. So it is a beginning value, which means it's our y-intercept. So we want to find the y-intercept. Well, we have, let's see, the slope. We can find the slope. Remember, this is x, this is y. It's the slope is the change in y over the change in x. Slope's going to help us find the y-intercept. The change in y is it's getting bigger, and it's getting bigger by 50 here, right? Positive 50. So x is getting bigger by 2, so we're going to write this as the 50 over 2, which is 25. So our slope is 25, and I'm going to use room down here. I'm still answering part A. This is where you plug in some values. You just found m, which was 25, and we have some x's and y's. In fact, I'm going to go ahead and use the first x and the first y to plug in. So y is 55, m times x, x is 1, plus b. Now I can find b, which is what I'm looking for. 25 times 1 is just 25. So that's what we have here to solve for b. Subtract 25. So what is the initial deposit? 30 buckaroos. The initial deposit is $30. And write an equation. B says to write an equation, so we're just writing y equals mx plus b. You need to plug in these two things. What was the slope? We found it up top, 25. And the b, we just found it, 30. Here you go.